Okay, we've started the recording. So I'm Raghu Balakrishnan from Mphasis, working with the FRB account for a while. Especially, I'm being associated with Donna and also with deposits technology, currently taking care of the projects in deposits technology. We're excited to have you at the integration booth in this exhibition, what we termed as an enCore virtual tech fair, conducted by Mphasis at FRB. Integrations make core banking transformation very complex. Dealing and addressing them is very critical part of our work. Hence, today at this booth, we are showcasing a couple of interesting solutions or accelerators, which has been built at Mphasis. Hope you would find it valuable for our core transformation journey. So this is a 1.5 hour session. And the first session, the first demo will be from 3 to 3:45. This demo is all about reliability engineering best practices honed by Mphasis and how these practices have helped our Mphasis clients significantly to improve the reliability of their application ecosystems. The demo by our presenters shall provide an overview of a proactive approach to reliability engineering using a minimalistic metrics framework. Our SRE approach applied to real-world banking scenario is showcased in this demo. And this is a demo. It will take care about 30 minutes. And then we will have a Q&A session. Feel free to put in your questions on the chat. We can pick up from the chat window and address your questions. If not, post this presentation at a quick demo, you can field your questions. So with no further ado, I want to introduce Rahul Dio, who is the presenter for today. Over to you, Rahul.
Thanks, Raghu. Digital experience is at the forefront of all touch points a company today has with their stakeholders. These stakeholders are not limited to customers. Employees, partners, government, and even competitions are coming together and increasingly putting effort to build an ecosystem. And when we talk about experience, it is not just optics or ease of use. Availability and reliability are also very important part of this experience. In today's presentation, we'll go over that aspect of engineering. Service reliability engineering, popularly known as SRE, has been there for a few years and rapidly evolved. Genesis of this technology can be traced back to Google, but then you have other big tech and commerce, digital commerce businesses. They had their own ways of dealing with faults. There are two broad categories or concerns when it comes to SRE. First, when a fault takes place, something has already happened. And the second is we try to prevent it. So when something has already happened, which is the first part, we try to gracefully recover the state. Second, we deploy assortment of technology interventions to prevent the fault itself. There are two matrices we measure here, popularly known as MTTR and MTBF. So on the left side, in the pink box, you'll see MTTR, which is mean time to recovery. And on the right side, you see in the green box, mean time between failure. So what do they mean? So mean time to recovery is if something happens in no time, if we could just gracefully recover the state. On the right side, which is mean time between failures, we try to increase the time duration so that the failure occurs less and less and at a very low frequency or high time interval. There are three parts to MTTR: time to detect, time to diagnose, time to repair. These are all also in line with the ITIL language, where all three are measured, and you can put all of them together to calculate your mean time to recovery. So how do we reduce MTTR? There are a couple of ways you can do that. Proactive monitoring, that's definitely a leading indicator. Then automate the diagnostics. So whatever diagnostic you have on all the hardware and software, run them and try to automate them. Runbook automation. Most of the mundane tasks you have either to restart or to refresh the logs or anything you see in your system which is being done manually can be automated through the runbook. And those can also be integrated in the recovery scripts. Chaos engineering is another approach which can be used more on the testing side of it, may not be on the production side, where you can induce multiple chaos scenarios. And in the demo, you'll see one of those chaos scenarios, which is inducing a high latency. We were able to disrupt the whole system. So what happens after applying all this? We try to squeeze the MTTR. So on the bottom, you'll see the pink box is kind of becoming smaller, and MTBF is becoming bigger. That's the overall objective we should go. Mean time between failure. There are a couple of things an organization can do here. Static code analysis. If we could automate that in our CI/CD pipeline or in our code walkthrough or just in the development tools. Many of these practices could be industry specific or could be organization specific. So those are the things your development teams, they need to bring together and encode in your development process. Status dashboard is more about culture. So if you show people, if you show your developers and testers and everyone who is responsible for it, especially in a scenario where dev and prod, they're all coming together as a single team. If they look at these dashboard and they're aware of what's going on, we see a significant amount of cultural change also, which contributes toward increasing the time between failures. Now let's look at one of the other common problem customers face. So very often I hear customers say, hey, I have 99 point whatever X availability on my systems, and I still have a lower availability. What's going on? So the challenge here is very often customers go about measuring these availability numbers on individual systems. What they should rather be doing is looking at holistic transaction. It could be a journey, customer journey scenarios. It could be a holistic service, or it could very well be just a transaction, very easy to understand. And we'll demonstrate this in our demo as well, how transactions are correlated. So here, if you see, there are two scenarios. On the left side, there is A, and then on the right side, you'll see availability of 94.1. If you look at the chain of all these transactions, they're all at 99.9%. So how come availability goes down when you have different combination of these transactions? On the left side, you see there are three of them in a single transaction. There are three systems whose availability contribute towards the availability of it. So availability, the general availability, is a product of all the systems. So if you have three systems in combination for a particular transaction, you multiply 99.9 into 99% into 99%, you will arrive at 97%. And that's a big surprise for many of them. And that's when they need to look at the transaction to ensure that the availability of the transaction is at par with what they're expecting. Same on the right side, if you see 6 of them, they contribute towards 94.1% availability, very low. And that's kind of not acceptable in many scenarios. So what's Mphasis approach? What do we tell our customers? So as a point of view on our customer, we advise them to measure kind of um, two kind of metrics, and I will describe those. We call it red metrics and then use metrics. So at an aggregate level, if you see these ellipses, they are at aggregate and also at course level. So you can either measure the entire flow of a particular service, or you could also deploy these agents to measure individual or coarse grained services. They could very well be a web service, a microservice, just a micro app, or just an old-fashioned SOA service. You can also monitor a database and see if transactions are coming through. Then you have other set of matrices, and those matrices are called red matrices, and these are discretely deployed or discretely monitored on resources. Those could be your CPUs, memory, network, and many other resources contribute towards the overall infrastructure. I talked about two indicators, the red indicator and the use indicator. So what happens, some of these indicators are leading indicators, some are lagging indicators. So error for sure is a lagging indicator because by then something has already happened. The only choice you have now is gracefully bring back your system and see if there are less fault, or if you have something already broken, you may have to go and fix them. The leading indicators are more important because that's where you have the opportunity of fixing stuff before the fault takes place. So one such indicator is like request. If you see consistently things are going up, and in the demo you will see if the request has suddenly spiked, there are high chances that your infrastructure may not be able to take that load if it is a fixed infrastructure. But then in cloud we have, or even on-prem, we have ways to scale out and scale in, and I will show you in my demo. The duration is the latency. So if the latency is coming in and it's just going up and up, there's something wrong, and it will eventually come and haunt because there may be something going on with the network. Then you have CPU and memory. So here, very often people complain that, hey, my memory is going up, my CPU is not going up. So what's going on? So in this situation, if the CPU is stable or it has actually gone down, that's the immediate sign that something is going wrong. If the CPU is going down in an ideal system, if it is not a batch process or a huge long-run process, the memory should also follow. It should definitely go down and have peaks and troughs. But if the memory is consistently going up, there's something going on in the system. And I'll show you in the demo how we go about fixing that. I'll talk a little bit about the demo, and then I'll run the demo because it runs for 15 minutes and we may run out of time. So I will kick off the demo and then come back again and explain exactly what's going on here. So here the setup is around an application. It's a simple web application you can see running in a Kubernetes cluster. It's an application with web tier. The web tier makes a request to a service name account, and the account in turn makes another request to another service named check. The metrics are being collected by Prometheus agents, the open source tool. We have in our demo, we have used all open source, and that's our IP as well. We call it XRAE. And then once we have all the data collected by these agents, the set of data is pushed to Prometheus database. Prometheus database is a time series database. You can bring in your own database. There are multiple ways you can configure this. Then we have Rundeck. It's a workflow tool We have used this workflow tool to run jobs. So these multiple jobs will be kicked in based on the alerts and based on what's expected to remediate a particular problem. So I have two scenarios here. Both are fault scenarios, scale out and scale in, though it's also a solution. But here what we have done is we have just loaded with, there's a sudden spike of 10 times of uh, load. So if you are going with 2x, you will see sudden spike to 20x kind of load. So what happens in those scenarios? Either your system will fail, or you have to put some threshold to not accept a load. But in today's business, request coming in is a very good thing. So you don't want to avoid scenario like that. Then we have chaos. In the chaos, what we did basically is we induced latency. There are three different kind of latency you will see: 6-second, 9-second, and 15-second latency to the check service. You see the check service here. And those latency will have impact on the overall availability. And in the script, we have put a threshold to contain that. And eventually what we do, we restart a server. And once the server has been restarted, you'll see slowly things again go to normal. So let me just restart the script, which is the demo script. So I'm running this in AWS EC2. It's an instance I have where all the setup has been done. So here you will see slowly in a couple of minutes. Yeah, now you can see that data flowing in. So there are three things we are collecting here. Let me start from the top. So you will see some alerts here. Give some time to show up here. Then we have flow metrics, which is rate. Then we have error. You'll find this empty because you may not see any. We have handled all the errors here. Then the duration, right? And all of them has been done at an aggregate level. So you have 1 minute, 2 minutes, and 3 minutes, and I'll explain them how they have and what kind of impact they may have on your system. Then I talked about the red metrics. So there are two parts to it. One is CPU utilization, and the other one is memory utilization. So we'll see how they are correlated and how they interact with each other and try to bring the fault back or try to avoid the fault. So I just kicked off. So I'll wait for any of these messages. Let me go back to my presentation. So I talked about two scenarios, right? So we have used rundeck, scale out and scale in. So you'll see in the chart, it will hit the load, and suddenly the load went from say 50 to 500, which is 10x. And then it has hit a threshold. If I don't do anything, then it will definitely not be able to sustain. It will start rejecting the request, and I will have loss of business. So what do I do about it? If my system has a way to bring in more servers in time to be added, which is scaling out, I would love to do that. And in our script, because we are in AWS, we were able to bring in more nodes, and we are able to scale out. And once it's done, we can again slowly scale in and release those services. So basically, we are getting on-demand infrastructure to handle fault. Then in case of latency, we'll see how 6-second, 9-second, and 15-second latency put a lot of stress on the infrastructure. And what do we do about it? So basically, those infrastructure latency may be because you have a deadlock, you may have a database lock, or you may have some other kind of stuck processes, and nothing can be done about them except restart. So what we have done here is we have automated that a runbook process, which is restarting the server. And once we restart the server, we'll see that gracefully things have been stored back. At the end of the demo, we should be able to see a matrix like this. So this is a request, so 10 times of request. So when we have 10 times of request, it's kind of reaching the peak. So what happens in that peak? So CPU utilization goes up, and very soon, if we don't do anything about it, it will start faltering. Same with the memory. Both are correlated at this point in time for this particular scenario. So what we do, we scale out. So if we see scaling out, then slowly things go down, go down, go down. Here also requests are going down. And gracefully, everything has been taken care of. And you see three of these lines. They represent different aggregates: 1 minute aggregate, 2 minute aggregate, and 3 minute aggregate. And those aggregates are also leading and lagging indicator. I'll show you how. And here you see scale out and scale in. So once we have automatically added node, it has been taken care of. And then slowly when the request goes down, we will see the scale in, the script triggers, and then it will release the server. And things are quite normal by then. Then we have another script which will induce three different kind of latency. And the moment we have those latency come in, we'll see, not in the graph, but we'll see a trigger where we have restarted the server at the background. And then slowly things have been gracefully taken care of. So let me go to the demo. This is a Grafana dashboard. So we have used Grafana here for visualization. And here you can see one of the alerts has already been shown. Now, what you do about these alerts are completely up to you. So it's a slower CPU utilization curve is about 30%. We need to scale out. This is just an alert we raised here, and then we scaled out using our script. If I go in the Kubernetes dashboard, I should be able to show you there. With limited time, I'll just show you the scripts we have written here. So let me just refresh. It's 6:30 Eastern time. Let's see what happened. Yeah, so at 6:25, scale out was kicked in. You see here, 6:25, scale out was requested, and scale out was kicked in. And you see here, these are the three graphs we are collecting here for the rates. So if you look at the 1 minute graph, of course, it will have more variation. If you look at the 2 minutes graph, it will have less. And then, of course, 3 minute graph will have a more graceful curve, right? So 1 minute graph will go down faster, second will go a little later, and 3 will go up. And these are all configurable based on what you want to do with your system. You can always configure. You can have a 30-minute graph as well to see what's going on with your system. And there is no error, of course, here. You can see here how the peak came in, and then it's slowly going down. Same happens with the CPU utilization as well. You can see the 1 minute with so much of zigzag, and then 2 minutes, and 3 minutes is more graceful. It goes up, stays there for a while, and then it comes down only after a while. Same here with the memory utilization. So it's running now. Let's see if there are any other alerts coming. Yes. So what happens after 5 minutes? Another script is kicked in, which says, hey, your CPU utilization threshold is below 15%. So I'm going to just scale in. You don't need more infrastructure. So why not just release those nodes and free up your cloud infrastructure. Let me refresh again. So you can see scale in script has been kicked in. So that was after 5 minutes. And I'll show you some of these duration remediation and significant duration also. It will show up eventually when the latency is kicked in. It takes just a little bit of time. So with respect to time, we don't have more than 10 minutes left, right, Raghu? So maybe we can start the Q&A and then I'll come back to the demo again.
Yeah. So we can open the Q&A session, and folks, feel free to unmute yourself and ask the questions.
Right. Raghu, Saurabh here. I
Yeah.
think we do have a question from Donna for Rahul
Sure.
in the chat window. So I will repeat for you, Rahul. What type of an assessment is done to ensure the product is compatible with existing technology application, stack, infrastructure? What is used to determine a baseline threshold?
So let me go back to this matrix, this chart basically. Here. So I would go by first defining what your user journeys are. If you don't have a user journey, I wouldn't say that's not that's unique. Very often, if you have a legacy system or system which has been developed over the period of time, you may still have some kind of aggregate service level or just at a transaction level expectation. So I would first go by defining for a particular transaction. For example, if a bank has a Zelle transaction going on, and in the Zelle, you want to see if the request to add or to send money, how many hops are involved. And I was talking about partners and competition and government. So Zelle is a good example uh, where you have a service which takes a request on your website. And from there, you call another service, which is a third party. And that third party has its own availability and its own latency and its own timeout. So once you go about that, check their availability, check website availability, and then see what kind of baseline you want to have. Now, you may be able to influence Zelle or any third party. If you cannot, then you have to consider that as part of your matrix and then calculate what your availability could be. That's how you establish your baseline. And then look at any of these hops, say in this case, this center one is Zelle, and after this, there's no control for you. So the only other way you can do is improve the improve the availability here and see if you get your desired result. Did I answer your question, Don?
Yeah, sort of. I mean, there's no recommendation per se. I mean, how would someone may not necessarily have those values? I mean, is there a recommendation of a baseline?
Very hard. I don't know those systems. Each system, if you have a legacy system based on the technology stack, uh, maybe our team Raghu and others, they can take a look at them and we can recommend some kind of availability. But again, I don't believe in any of consulting folks would recommend the availability. It should come from business or the IT folks based on what you have on the system. So if the system is little old, presumably, very hard to have a higher baseline on them. But if you're moving to cloud, or if you have refreshed your infrastructure, it's fair to expect a high availability of those systems.
Okay. Understood. Thank you.
Sure. So before I go to other ones, let me just read these questions. These are very frequently asked questions from our customers. So how different is the setup in cloud compared with on-prem? Uh, a general answer would be not very different, except if you have a lot of native services being used in cloud, then things might change differently. But if you're just moving in your infrastructure as is, um, then little can be done there. However, if you're not moving in entirety, if you have combination of them, some in on-prem, some in cloud, um, then of course subtle things need to be considered uh, before you arrive at a baseline and then start measuring them. The second one is, how is the configuration flow managed for multi-cloud environment? So I think I was just trying to explain, Dana. Similarly, it does not matter whether it's a cloud or it's a service outside of your cloud. That's not a concern whether it's a cloud-based system, it's a non-cloud-based system. It's just it boils down to the latency and the response time. So if you put them together, you should be able to arrive at a baseline. And then the flow management and the monitoring accordingly has to be configured. What are the next set of improvements Mphasis is doing to this tool? So we have this tool, the demo I just shared. So the name of the tool is XRAE, Accelerated Service and Agility Framework. And we have a product team. We keep adding stuff. So if you're interested to know more about that tool, we can arrange a separate session for that. What are the popular tools that used? So here, if you see, we have used a combination of open source tools, Prometheus for storage of the data, which is a time series data, and also Prometheus agent for collection of data. You can use a COTS product or any combination of it, say AppD or any other product. And then we have used Rundeck to run the script to automate the stuff. And then we have also used Grafana for the visualization. You can choose other tools as well. Some products come with the whole combination. They may be expensive, less agile because they come pre-built. So changing them, configuring them could be difficult, but then they come ready out of box. The last one, what is the typical time frame to build a basic monitoring? I would say not more than 2 weeks just for basic monitoring. If the toolset is already available, and if you use our XRAE, for sure you can arrive at that. But then again, it's just a basic monitoring. I'm not considering any kind of access control or access or approval time. More often, it takes more time to get the approval than writing the script. But if it is just writing the script, probably 2 weeks is fair to expect. So before I go to the question, let me just go back to the demo again and show you how things have shaped up there. So here you can see scaling happen. There was an application duration email alert sent because there was a huge latency induced. And then a restart required. So we actually did the restart, but you can send this email or you can generate an event. There's also a good system to do event sourcing if you want to attach to your event systems. And you see how slowly things are settling down here. CPU going down after the huge latency. And then memory also kind of settling down. And you will see a result of all the graphs will show something like this.
So Rahul, I would like to add one point on the fifth question. What is the typical time frame to build a basic transaction?
Go ahead.
Right. So as Rahul said, it can take minimum 2 weeks, but the important information that we need to collect in order to build robust monitoring, which is start with basic, is to identify your service level indicators, which is very well known, the golden signals, latency, request rate, error rate, and all that. So those four golden signals you anyways are going to put in your monitoring. Well, very important is service level objectives need to be determined working with your business partners or technology partners. Donna's question was how you determine the baseline. So um, that's where it comes. So when you do performance stress test on your isolated system, then you know how much load your each system is taking. So that's where you plan your capacity and ensure your threshold is built for monitoring tools and arrive on your SLO. Okay, so you have a better understanding on your system that, okay, so this system can take X number of load, it fails at a point, and now my objective would be this. So when we have those critical information captured, um, building the first basic monitoring is very easy. So many tool supports AppD, New Relic. Um, there are plenty of tools supports that kind of a business transaction monitoring.
Thanks, Sophia.
Yeah, yeah. Coming back to the first question, like how the assessment can be done for the application stack and the infrastructure. So each stack has a different assessment patterns. Like if you go with infrastructure, we go with memory, CPU, threads, memory threads, and how much is the CPU threads and blockings and everything. When it comes to application assessment, it mostly whether it is a web application or a on-prem application, whether it is how much is a browser compatibility and other things come into this assessment when we go with a product with this. So these all will be taken care of. Great. Thanks, Rahul, Shafi, and Venkat. So we have come to the end of the demo here. Thank you very much for participating. So if you've got any more questions, feel free to reach out to me for any questions. And if you need a deeper demo, I will check. So this is could be one of the important aspects, network performance or application performance for either the IS or the different teams. So we can look into this. We will take a short break of 5 minutes now and restart the second demo. The second demo is on APIs on APG. So basically, if you look at it across all the squad teams across FRB, we are building out APIs like dime a dozen, right? So when we are building so many APIs, having a CI/CD pipeline, building it, any changes happens, building it, compiling it, building it, and deploying them into the APG servers is very important so that it can be consumed and tested properly. So many, for example, if I take some live example, we did encounter a problem wherein we deployed it and there was an issue. So we need to build in some testing also during the deployment period. So all these things, so the automation or building a CI/CD pipeline, especially when you are building huge number of APIs, it could be very important to an organization. And this team has built in such an automation tool, which has helped many of Mphasis customers to utilize it and move forward. So Rajesh Balan would be the presenter. So we'll take a short break and come back and see the API on a PG demo. Thank you, folks. We probably we will take 2-3 minutes and get back, and we can start off. Thanks, folks. Thanks, Rahul.